Okay, so exercise 6, let me show you the answers. Then you let me know whether your answers are correct or wrong. Okay, if it's correct, put a tick. If it is wrong, let me know, then I can go through it with you. Otherwise, we will assume that it is okay. Okay. Family friends, it's okay. Okay, determine whether the following is a prime or composite. So for part A, prime, we have 23, 47, and 53. Okay, then for the composite numbers, we have 9, 25, 45, and 70. So that's 7 numbers, 1, 2, 3, 4, 5, 6, 7. Okay, so I have accounted for all numbers. Since we are at this, can you help me remember what is the smallest prime number? Is it 1 or 2? 2, very good. And what is the next prime number after 2? What is the second smallest prime number? 3. What comes after that? 5, and then 7, and then 11. Okay, you are correct. Okay, good. We will need this knowledge for subsequent parts, yeah? So part B, determine the largest prime number less than 30, that will be 29. Part C, difference between smallest and largest prime number between 30 and 65. So the smallest is, that will be 31. Largest is 61. So, okay, so you look at this thing that I'm drawing over here. These 3 dots. In mathematics, we like to save time. We like to make things easier for us. And this is important, Sean. Listen. So when I draw these 3 dots like this in a triangle, it means therefore. Okay, it also means so. It also means hence. Okay? So in other words, I have the smallest prime number is 31, the largest is 61. Therefore, difference equals to 61 minus 31, and we put equal signs we stack them up like this, 30. I don't like to have many equals in one row, so it shouldn't be the case. We should put our equal sign down in one neat row, okay? So that's presentation. Next, question 7. Okay, this one is interesting. Did you manage to figure this out? Okay, who thinks P plus Q is 24? Answer 24. Like this? Okay, it's the correct answer, but why must it be 24? Can there be any other answers? Can there be any other answers? Why not? What is a prime number? 23 is a prime number. Oh, you're right. This is a prime number. It can only be divided by 1 and itself. Okay, so P and Q, they are whole numbers. So we've got 1, 2, 3, so on and so forth. P times Q is 23. So this tells us that P times Q must be equal to 1 times 23. There's no other option. But does this mean that P is 1 and Q is 23? Can it be the other way around? Can be the other way around. But the question is not asking you to find P. It is not asking you to find Q. It is asking you to find P plus Q. Must therefore be 1 plus 23, which is 24. Okay, whether it's 1 plus 23, 23 plus 1, you still get 24. And that is how we get the final answer as 24. And look at this symbol over here that I'm using. You see that? Have you seen it before? Oh, you all learn so many things in primary school nowadays. Okay, so we typically put that at the end of our answers, right? Because sometimes we have a lot of working. Then we want to just zoom into the final answer. We put 2 dashes, two slashes at the end. Okay, next. We have prime factorization. Let's do a recap. In primary school, how did you find things such as highest common factor? I know you've learned it before, but how do you find highest common factor? For example, if I want the highest common factor of HCF of 52 and 48, how will you do this? list it out. Okay, good. So factors of 52 equals to 1, 2, blah 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 blah. Factors of 48 equals to 1, 2, blah 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 blah. And then you find the highest, right? Highest common one. That was how you did it. Let's just show you something over here. I'll just show you the next few pages. Just for an example over here, find the HCF of 27, 63 and 207. So are you going to list it out? I mean, that's what you have learned so far only, right? Since primary school. But if numbers get really big, then there might be some other way to find HCF instead of listing everything. And that requires us to be familiar with what we are about to go through, which is prime factorization. Okay, so prime factorization is simply a product of prime factors. Okay, does it sound confusing to you? A product of prime factors? Who thinks you fully understand what this phrase means? Product of prime factors. We understand. So nobody is fully confident, right? But don't worry, we will go through it. What does product mean? Product, what does product mean? Show me, what does product mean? Plus, minus, times, or divide? Times, yeah, product means times. Okay, so we're going to multiply. What are we going to multiply? Prime factors. So numbers have many factors. For example, 30 has a factor of 2, factor of 3, factor of 5, factor of 6, 10, 15, and 30. But out of all these factors, which are the prime numbers? Only 2, 3, and 5. Okay? Although, for example, although 10 is a factor of 30, but is 10 a prime number? No, it is not. So we are not going to include this in the prime factorization. We only want to pull out prime numbers, okay? So we can only do this for composite numbers because composite numbers have more than 2 factors. So examples over here for the prime factorization of 30, we will break it down to 2 times 3 times 5. Are these prime numbers? Yes. And you mentally do it. 2 times 3 is 6. 6 times 5 is 30. So we have broken down 30 into product of prime factors. Similarly for 60. Oh, it's a big number, but it is simply 30 multiplied by 2. All these are the same. You see that? Okay, so big numbers, they are reduced into the prime factors. There are 2 methods that we can do this. I'm going to show you both methods, but I'll let you decide which is your preferred method, okay? And you might find it familiar also. So let us start with exercise number 8. It is repeated division. So first we write 2, 5, 2, and we do this. Have you seen it before? Yeah, I think you've seen it before also. And what is our next step? We put the smallest prime factor on this side. What is the smallest prime factor? 2, because 252 can be divided by 2. And what are we left with? 126. You use this opportunity, right? Do your mental sums. Put 2 again, yes. And what do we have? 63. Okay, hang on. I always want to put in the smallest ever prime number. So far, 252 and 126 can be divided by 2. So I've been putting 2's. But when it comes to 63, it is an odd number. Definitely cannot be divided by 2. So I have to put in another prime number. What is the next smallest prime number? 3. Very good. And we are left with 21. What is the next smallest? Is it 7 or 3? 3. We always put in the smallest prime number. And we are left with 7. And then what happens? 7 again. And we are left with 1. This is when we stop. Okay? So this is just a method, a presentation for us to extract, to take out all the prime factors. And we did that by doing repeated division. So, my symbol over here appears again. So, 252 is equals to 2 times times 3 times 3 times 7. Okay? Do I need to put times 1? No need. Okay, and then if you look at this, my numbers, they are arranged in ascending order, smallest to biggest. And now the small numbers will come together first, right? I won't have a 2 times 3, then suddenly times 2 again, then times 7 times 3. Why? Because I did things very neatly. How do I do it neatly? I always divide by the smallest possible prime number. Okay, so now it is your turn to try part B. Express 1 to 5 in prime factors. Show you this. I usually do it this way, 125. Then I will draw this vertical and horizontal line. And then I put a 5 over here. And as I keep going on, I will keep drawing it. I saw some of you did it this way. $125, and then you draw a line. You see the difference? One is I draw these two strokes as I go along. But some of you drew a vertical line like this. The issue with this is that you may end up with excess lines. Then there's like this very big gap over here, which I find it a bit weird lah. Okay, it's fine, but I prefer to do it this way. Okay, I prefer to do it in blue. I'm not saying whatever is in red is wrong. So 5 over here, left with 5, another 5, and I'm left with 1. Okay, so we have, and we need to write out our final answer. This is just a working, it is not our final answer. Our final answer is 125 is equals to 5 times 5 times 5. This is our final answer. Any issues? Okay, moving on. Find the prime factorization. Next one is using the factor tree. I saw some students, you already moved ahead, which is okay, but you didn't read the instructions. You were using the repeated division for exercise 9. You should be using the factor tree. So let me introduce you the factor tree. So we start with the value again, 216. But this time, instead of our repeated division, we branch it out this way. It should be familiar to you also. So again, we have similar steps. What is the smallest prime factor of 216? 2, it is an even number, it must be 2. So mentally, let's calculate 108. Okay, so we branch it out, become 2 and 108. We look at both of these factors and we work on the factor that is composite. Okay, so between 2 and 108, which one is composite? 108. Okay, so this one, these two, we stop here already. Okay, let's branch out 108. We can divide this. What is the next smallest prime number? 2 again, followed by, what is the other factor? 54. Okay, then let's branch out again, 2 and 27. Okay, now when it comes to 27, what do we have? 3 and 9. When it comes to 9, what do we have? 3 and 3. And can we divide anymore? We've come to the end already. So let us identify all the prime factors. So I have now underlined all the prime factors. In other words, final answer 216 is equal to 2 times 2 times 2. Okay, there are 2 2's over there, multiplied by 3 times 3 times 3. Okay? And now it is your turn. Please try for part B, 360 using the factor tree. And as you go about doing it, please, so 360 divided by 280. If possible, try and do it mentally. 2 and 45, 3 and 15, 3 and 5. Okay, so identify all the prime factors. So our final answer is 360 equals to 2 times 2 times 2 times 3 times 3 times 5. Do you have the same answer? If you do, please give yourself a tick. And please take note that this is our final answer. Okay? Jimmy, do you have your final answer written down? Or do you just have your factor tree? Okay, any questions before I move on? Then let me do a quick survey. There's this question. Is it troublesome to write 125 as 5 times 5 times 5? Is it troublesome? Think imagine. Actually, 5 times 5 times 5 is not so troublesome one. But what if we have a number like 64? We're going to divide it. Okay, let's just see what this gives us. 32, 16, 8, 4, 2, and 1. Okay, so 64 is equal to 2 times 2. Can you please stop me when I reach the correct number of 2's? Is it ready? So 6 of them. Is it troublesome? Yes. Is there a simpler way of doing it? Do you learn powers in primary school also?
Yes.
Learn by yourself in primary school?
Yes.
I believe you learn square, right? So for example, 4 square, you learn this? But do you learn 4 to the power of 6?
Yes.
Yesterday night. Okay, you watch the video, is it?
No, I read math book.
Okay. Now let me tell you a secret. People who do mathematics are very lazy people. Why do I say they are very lazy people? Because when we come to problems like this, 64, and you have to write so many times, we want to find it's very messy also. We want to find a way to simplify things. Too lazy to write so many things. So we write this as 2 to the power of 6. Is it easier? So you see there, you know, oh, it just means that it is 2 multiplied by itself 6 times. It might be, you might confuse it with 2 times 6. So this one over here is, okay, what I drew, equal but not equal. Okay, so this means not equal to. 2 to the power of 6 is not equal to 2 times 6. They are very different. This gives us 12, whereas this is 64. Okay, when numbers become really, really big, or when numbers become really, really small, we will find this power over here very useful. And it sounds to me that you're already familiar with the names of this. So 5 with a little 3 on top is read as 5 cubed. B-E-D. 5 cubed. Or the cube of 5. So the next one, 5 to the power of 2 is read as 5 squared. Or the square of 5. So sometimes square 5 to the power of 2. So in this case, 5 to the power of 4 is known as 5 to the power of 4. Okay, please make sure you have all these written down properly. So here we have 5 to the power of 6. Let's check. 1, 2, 3, 4, 5, 6. Okay, it is correct. And when we are familiar with numbers, we can simply replace all the numbers with letters. Then we have to do more general form. In this case, we have A. A times A times A times blah 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 times A equals to A to the power of n. So how many A's do you think there are over here? How many A's are there? N. Okay, so there are n number of A's. Okay, so you just understand what this means. So what do we call this method of expressing numbers? No, we don't call it to the power. We call it, in this blank, index notation. N-O-T-A-T-I-O-N. Notation. Index notation. Notation just means a way of writing things. Index over here, this thing that we always call the power, the little number on top, is actually known as the index. The power, if you like. So by writing 25 as 5 squared, we are writing in index notation. The index is on top, and this 5 over here is known as the base. Okay? It's just a name, okay? So when the question asks you, oh, express this as index notation, you must know what they want. Okay, so express this as index notation. Well, we're not asking you to calculate. We're not saying, oh, find out what is 7 times 7 times 9. And then you write 441. 441. Then it's wrong already. That's not what the question wants. The question wants you to write the following index notation. So I want to see a power. I want to see a base. Okay, so this is 7 to the power of 2 times 9. Get the idea? Okay, do the rest for B and C. Part B. We've got 5s and 13s. These are both our prime numbers, our prime factors. So how many 5s did you count? How many of them? G3C, that's you guys, yeah? So 5 to the power of 4 times 13 to the power of how much? 4 also. Okay, next one. How many 2s are there? Should I write power 1? No, we shouldn't, because there isn't a need to. So we leave it as 2, then multiply by 5. How many 5s are there? 4 again. Times 7 to the power of 12. 3. We've got 3 7s over here, we've got 9 7s over here. Altogether we have a total of 12. Did they ask us to evaluate, use our calculator to find out the value? No, they didn't. Leave it like this. Okay, so this is a question that does not require usage of calculators. So moving on, exercise 11. Express the following product of prime factors using index notation. So I haven't asked you this question yet. Do you prefer your numbers? I'll be using the repeated division. So 108 divided by 2, 54. This sounds familiar. I think we've done this just now. 27, 3, 9, 3, 3, 3, 1. And I stop here. Therefore, part A, 108 is equals to 2 to the power of 2 times 3 to the power of 3. That's my answer. So please try part B now. Final answer 192 is actually equals to 2 to the power of 6 times 3. Okay, if your okay is correct, your final answer should also be correct. Now for the last one, exercise 12. You may discuss with your partner. So let us, the first step to solving a problem is always to understand. Only when you understand, then you have a chance at solving it correctly. So a number has exactly 8 factors. 8 factors, nothing more, nothing less. Based on this sentence, right, what is the smallest factor? What is the smallest factor of any number? Did I say prime factor? No, I didn't. So what is the smallest factor of any number? They are not asking for prime factor. So what is the smallest factor? 1. But if I ask you what is the smallest prime factor, what must you say? 2. Okay. So I know that the smallest factor must be 1. And then there are 7 other factors which I must find out. 2 of them are 8 and 20. 8 and 20, are they prime or composite numbers? They are composite numbers. That means I can break them down. Okay? So let's start by breaking 8 and 20 down. You can do your repeated division, or you can use your multiplication like this. 1 times 8, 2 times 4. So for the number 8, how many factors do you see?
4.
4 of them. 1, 2, 4, and 8. Okay. Then for the next one, 20. What are the factors for 20? So we've got 1 times 20. We've got 2 times 10. 4 times 5. Should I continue? No, I shouldn't. Okay, so let's pause and think over here first. If this number that we are trying to find out, it has 8 factors, out of which 2 of the factors are 8 and 20. Does that mean that the number 2 should also be part of these 8 factors? Does it mean that? Yes, right. Because 8 is a factor. So since 2 is a factor of 8, then 2 must also be a factor of that number we are trying to find. You get the logic so far? Okay, so I'm now going to circle the factors which I know exist in this number. Okay? What is the smallest number again? 1. Okay, let me circle that. I've got 1, I've got 2. What is the next smallest factor? 4. Then what is the next factor that you can see? What is the next factor that you can see? 5. Okay, wow. I was expecting you to say 8, but you actually can cross-reference both sides. Very good. The next one is 5. What is next? 8. How many do we have already? We've got 5 factors already, huh? What is the next one? 10. And what's the next one? 20. How many do we have all together now? We have 7. I still need one more. What could it be? The number itself. Right? The number itself, whatever that number is, must be the last factor. What do you think it is? Good job, you all can do O-level question already. So the factors are answer 1, 2, 4, 5, 8, 10, 20, and the last one you have identified it to be 40. Yeah? Okay, so I'll leave it as a blank first. How do we know it is 40? If you notice the way I write down the factors of 20, I stop over here, right? 4 times 5. I do not continue with 5 times 4, 10 times 2, 20 times 1, right? I don't do that because it is just a repeat. The smallest number and the biggest number, the smallest factor and the biggest factor when multiplied together gives me 20. The next smallest and the next biggest multiplied, it gives me 20 also. It is like a symmetry over here. This is like a mirror image. In other words, 1 multiplied by this number, by the last factor over here, should give me a value that is equal to 2 multiplied by 20, which is how much? 40. And you keep counting. Okay, 4 and 10. What do we get? You get 40 as well. And then 5 and 8, you multiply them, you get 40 also. So the blank over here must be 40. Okay? Quite fun, right? Okay, I shall stop this recording over here. Okay, please take note over here. Homework, textbook, exercise 1.1, question 5, 6, 9, and 10. So, you need to refer to your textbook, exercise 1.1. Do these 4 questions on foolscap paper. And when you answer the questions, at the end of it, flip to the last page of your textbook and self-mark. If it is correct, give yourself a tick. What happens if you get it wrong? If it is, when you're doing self-marking, you don't need to cancel. Just put a cross and do your corrections on the side. Attempt the question again in green. If you still cannot do it, then how? You already tried once and you cannot do it. What should you do? Try again. You tried 2 times already, you still cannot do it, ask a friend. If your friend cannot help you, ask another friend. If all your friends cannot help you, I will teach you in class. I will go through homework questions. Okay?